All right, so I'm going to put this next to here. I'm going to get rid of this. And I'd like to kind of create all of that in Postgres. And by the way, you know how to do that. It's actually not that hard to do. Creating a book is pretty easy, right? Because it just has an ID, book title, ISBN, and number of pages. Creating an author is pretty easy too. Creating a book author should also be, should be somewhat easy, because this author ID column is actually a foreign key to this column, to this primary key. And this book ID column is going to be a foreign key to this primary key, because again, those numbers have to map to an existing book clearly. And those numbers that you see here have to map to an existing author. Each one of them has to map to an existing author. Otherwise, it would be kind of confusing to put an author ID that doesn't exist. So essentially, that's what a many-to-many relationship is. You have kind of two tables that don't have any foreign keys, and you have a bridge table that has two foreign keys. One of them is mapping to one of the primary keys for one table, and the other foreign key maps to the other primary key in the other table. And of course, this ID is not really, we're not using this, but because all of our tables should have IDs, we can keep it anyway. So I hope kind of that that makes sense. Let me look at the chat window. Okay, do you guys have any questions before we start coding? We're gonna do that in Postgres. So I'm gonna open my console here. So let me hide this, and I'm gonna open my console. Let me open the default console, that's fine. Okay, let me open the chat. Keep it open and the participants. All right. So I'm going to start by creating book and author. That's pretty easy, right? I'm going to say create table book. And actually, we have to use lowercase. And we can use kind of a nice way of formatting it. And what do we have here? We have ID, which is serial. So we can use serial. And of course, we can say it's a primary key. And we have book title, and that's going to be varchar. I don't know, maybe 200. That's okay. And then we have book ISBN. I don't know how many characters. I like to use uppercase characters. That may be 9. I think it's either 9 or 11, maybe. And then we have book num of pages. That's going to be an integer field. Okay, we don't need the comma here. That's good. Of course, we can run that. I'm going to highlight this, run it, make sure that it's working. It kind of seems working. I can look at the database. I can actually, did we have book before? Let me see. Or was this just created? I think it was just created. Let me see. Book. Yep, I think this is the one that we created. We have ID, book title, book ISBN, book number of pages. Okay, that's good. That's for book. Let's do author. I don't think we have author here. So let's do author, say create author, create table, author. And same thing, ID, serial. And I'm going to say primary key. And then I have the author name. So author name, and that's going to be varchar. Varchar 200 is okay. And then author is alive, and that's going to be Boolean. And then I have author nationality. That's going to be varchar. say, let's say 100, okay. And of course I can create that. I can highlight all of that and do this. And you can see it'll take a second and author has been created. You can see here, I have 4 columns and that's how it is. So that's fine. You know, I can open author. I can actually have, I can write some stuff here. And of course I can open book and I can write some stuff there too. Okay. So let's see. Let's go here. Okay, so let's create this kind of this bridge table, and I'm going to call it book author. Why not? So I'm going to say create table, and I'm going to say book author. And of course you can have an underscore here. That's perfectly fine if you want. And what do we have? We have, of course, ID, and that's going to be serial. That's going to be primary key. Again, that's going to be this column. And we're going to have an author ID. So author ID, and that's going to be, again, the foreign key to this column for this table. I hope kind of that makes sense, because you know that's what we've been explaining. So, okay, so what is this one? This one is going to be an integer, an int. And then we can say references. That's one way of creating a relationship. And then we put the table name, which is author. And between parentheses, I'm going to say the column name, which is ID. That's really how it is. So I'm going to say book ID. You need to know that. You need to memorize that. It's really not that bad. Book ID. Like that. Do you guys have any questions about this? Do you guys have any questions about this? All right, let me run this one. I'm highlighting this. I'm going to hit play. You can see that it's worked. I think it has worked, and it'll, you know, we can reload that, and we should see book author here. Do you see book author here? Okay. And again, we can fill it with information. So we can go to book. We can say, again, we don't need to specify ID. That's going to be a serial, so it'll be auto increment. Again, let's say book 1. That's going to be consistent here. Book ISBN, well, we can just keep it null, and we can keep this one null. That's fine. We can add a few other, how many books do we have? Let's add 3 of them. So book 2 and book 3. Kind of let's match what we have here. So these are the books. We can create 4 authors. That's perfectly fine. Author 1, author 2, author 3, and author 4. So we have authors here, we have books here, and then when you want to make the connection between authors and books, you would go to book author, and we would do kind of what we've done here. So we would say the author ID 1 actually published book 1, but book 1 was published with actually author 2 as well. So like that, and you would save that. And you can create, you can say, for example, the author number 3 published book number 2. That's just a single author. And you can have 2 of them. You can say author 1 and author 4. They published book 3. Both of them published book 3. And of course, you can say author 3 published another book. Let's actually add another book. Let's add book 4. So if we go to book here, let's add book 4. And then let's say, when we go here, we can say author 3 published book 4 as well. I mean, that's fine. So here we can say author 3 published book 4, just to kind of show you the many to many from both sides. So here, for example, author 1 actually published or co-published book 1 and book 3. And also book one has been authored or co-authored by this author and this author. So you can see there's many-to-many from both directions. If you look at just one number, which is one, you see one goes to one and one goes to three. So you have from one unique number, which is one, goes to both two different numbers. And from here, from 1, we go to two different numbers. So that's many-to-many. You need something that looks like this to create or design a many-to-many relationship. Do you guys have any questions about any of this?
I have a question, Professor.
Sure, Sweat.
So while creating the book author table, we didn't use the while coding it, we didn't use the keyword foreign key. So that means that we would use that foreign key keyword just to code like one-to-many relationship.
Actually, no, we don't have to use foreign key for one-to-many. However, I think we've used two different ways to create. So that's a good question, Sweat. I think I know what you're referring to. So let's go back to here. So here we can say references. That's one way of it. And I can show you another way using foreign key. I think now I know what you're saying. So create table book author, and I can say ID, which is serial and primary key. And I can say author ID, which is an int, or I can even say big int. It doesn't really matter. Let's just do int for now. And let's say book ID int. And then we can do constraint. I think maybe that's what you're referring to, because we've done it maybe like this. And then say we can say foreign key author ID, or just foreign key author, we give it a name, and then we say foreign key, and between parentheses we say the foreign key is ID, and we say references. Let's see, the foreign key is not ID, is author ID, and the references the book author, in this case book author, and between parentheses we say ID. So let me kind of show you this and pause for a few seconds. Of course, you can add another constraint like this, and foreign key kind of book like that, and we can say it's actually book ID and references. Oh, this one should not be book author. This one should be author, and this one should be book. Okay, and let's get rid of that comment. So these two are essentially identical, and maybe that's what you're referring to, Sweat, because maybe we've talked about this. I think we've talked about this too, but these two are different. So you can, these two are the same. They do the same thing. So you can mention that it's a foreign key here right after you define the column, and you don't have to use the keyword foreign key, or you can just create 3 columns and add 2 constraints that create that foreign key essentially constraint. But even if you do it like this, the constraint will be added, just to kind of make sure that we're on the same page here. I haven't, by the way, I haven't run this one. I only ran this one. And by running this one, I have book author. And if you expand this one, you see that it has 2 foreign keys. So it gave them different names. So here the names that we gave them were FK underscore author, but really the names that the names that were given using this were different: book author, author ID, FK. It doesn't really matter what the name is, but essentially it did create two constraints, and it gave them names, and it also created the relationship. It's from author ID, which is kind of from here, to the ID of table author. And this one goes from book ID to the ID of book, kind of similar to what we're defining here. It's just there are two different syntaxes, and one of them, of course, is kind of cleaner and easier, which is this one. And in this case, you don't have to worry about kind of giving it a name too. So this has nothing to do with many-to-many versus one-to-many. You can go with this syntax or this syntax when you define many-to-many or when you define one-to-many. This has nothing really to do with the fact that we're doing many-to-many. Does that answer the question, Sweat?
Yes.
Okay, all right. Any other questions? So this is another syntax that I'm gonna just comment. Okay. So if you want to get, for example, all the books that were published by a specific author, then let's say you want to get all the books that were published by author number 2 or author number 1, you have to say, okay, find me all the ones that have 1 here, and that would be these 2, and then these are the 2 books. If you want to get all the authors that published a particular book, you can say, okay, let's get the book ID, which is 1, and we're going to get all the authors. In this case, it's just 1 and 2. So that's how you do the querying. I want to show you how you can do that in Django, but I don't think it's a good idea to do it now because we only have 10 minutes and I don't want to rush it. I prefer to kind of take my time and have you ask questions if you have any questions. Let me see. Do you guys have any questions? We have 10 minutes left. So if you look at the tables here, all of those tables have columns, of course. You can, for example, if you look at book, you can expand those columns and you can see there's 4 of them. They're the same columns, of course, that we used when we defined a book. And also it has keys, and those are primary keys. So we have just a single primary key here. So if you expand this one, it'll tell you that's the name of it, book P key. It's a primary key from the color of this and the column's ID, which is this one. And it shows you something called indexes. Now we haven't talked about that, but essentially every time you create a primary key, it creates an index for this column. And essentially what it does is it makes searching through the ID fast. So sometimes we do something that looks like this, right? We can say, gonna select star from book where ID is equal to 100. Okay, that's a correct SQL syntax. Now, because ID is indexed, so there's an index for ID, it makes running this sentence very fast. Makes running this command very fast because it's indexed. And by default, all the primary keys will be indexed because a lot of the times we do actually search items through their IDs, through their kind of primary key. This is typical practice. And because of that, Postgres automatically creates an index for the primary key. And it's easy to create an index for a primary key. Indexes, we can talk about indexes at some point, but indexes uses hashing, which we've talked about before briefly. And it's easy to create, it's easy to index unique, kind of a column that has unique values. And of course, it's easy to index something that is an integer. But you can add indexes for anything. For example, let's say in your application, in your website, or in your app, you tend to do more things like that. Gonna select star from book where kind of book title is equal to something. So if based on your application, if you do a lot of searching that looks like this, where you actually ask a question about the book title, what you could do is you could index this one. So you can add an index to this one, and that would make searching through or using book title fast. So based on your application, you want to determine which columns you want to index, and you want to index the columns that you typically use when you search the database. Does that make sense, guys? Give me a reaction if that makes sense. Okay. All right, that's good. Not too many reactions, but if you don't have any questions, I have to assume that it makes sense, and you're going to be quizzed on it. So the best thing to do would be to ask questions when you have questions, so that you don't have to kind of go rewatch the videos and study that again. That's not a good use for your time, really. Okay, any other questions? So the question that I have for you, why don't we index all of them? Anybody knows? If we index this one, we can search through book title quickly. And if we index this one, we can search through kind of the book ISBN quickly. And if we index number of pages, we're gonna search through the book number of pages. Why don't we just index all of them? Sweat, what do you think?
Because they are not primary key, the values can vary. That can be the reason.
So they're not primary keys, but you can still index them. So when you create a primary key, this gets indexed by default. Essentially, there's an index for it, so you can search using the ID and it'll be very quick. But you can add indexes to those. You can create an index for this, create an index for this, create an index for this, and they don't have to be integers, they don't have to be primary keys, they can be anything. You can still create an index for those. So why don't we do that anyway, regardless of whether we're going to search like this or not? That's a question that I have. Anybody knows the answer to this? Why don't we just simply index all of that so that regardless of what we search for, it'll be fast? I mean, you can do that, but there's a problem with that. It's not a good practice to create an index for all of them. All right, I'll tell you the answer to my question. The reason why we don't index all of them, because indexing takes space. So when you index this one, when you say I want this to be I want to add an index to this one so that I can search for it quickly, that's going to actually consume space, memory. So it becomes fast, but it consumes more space. So there's a trade-off that you have to make. And you don't want to index all of them. So if you don't usually search like this, if you don't search by ISBN, which actually most likely you'll be searching a lot by ISBN if you have an application, where you have books. But let's say you don't search by number of pages. Let's say that's not typically something that you use when you search. Although you could, right? You can say I want all the books that are between this page and this number of pages and this number of pages. That's actually would be useful. But let's say you don't typically do that, then it wouldn't make a lot of sense to index this one because it'll consume space. And you don't just want to do it, for the heck of it, right? You want to make sure that when you design your database, you want to make good decisions, right? Even though your database might be very small, you want to make sure that you make decisions that make sense. And it doesn't make sense to index this one if you don't search, if you don't make queries that look like that.